Yes, good afternoon, ladies and gentlemen. On behalf of the Arab Union for Sustainable Development and Environment, I would like to thank you for joining us for this valuable webinar regarding the electrical vehicle infrastructure. As we can see in the near future, the electrical vehicle will be in charge in our lives. Now all the world are talking about the climate change and reducing the carbon emission. And the target to reduce that carbon and to increase the participations to keep our earth clean. On that matter, all the manufacturers of auto companies, they are heading to increase the share of electrical vehicle. So the question that we have is it our countries are ready to implement these technologies in our life? At the same questions, can we use it in the right way? Especially to reduce the emissions. How can we do that? Is the charging stations will be fed by conventional power stations or can be fed by the renewable energy? And that's why we came up with the idea of this webinar with our professionals and esteemed speakers who are expert in this field. So we'd like to welcome our speakers, Mr. Andrew from England, and also Dr. Ahmed he's in the USA, and also Dr. Mohammad Zamri, he's from Malaysia and he's working in Qatar. Also, we have Dr. Mohammad Alam, he will join us later on. And also we have Engineer Adib Al-Amin. He also will join us soon when he gets the problem of link fixed. Now we will start with Dr. Mohammad Zamri Wanik. He's a senior scientist at Qatar Environment and Energy Research Institute, which is called QEERI, and he will talk about the sustainable energy solutions and smart grid integrations. Dr. Mohammed, you can start your presentation. The floor is yours. Yeah. Mr. Dr. Mohammed, you can unmute yourself.
Yeah, thank you, Engineer Salim, for the nice introduction. And also, I'm very great. I'm feeling great to be here, invited to be one of the speaker of this session. So I'm not sure if you guys see my screen, my slide.
Yes.
Is it?
We can.
Okay. Okay, so my presentation is on sustainable energy solution and smart grid integration related to electric vehicle infrastructure. And so, hang on, why it's not moving? Okay, so the time is only 10 minutes, so I cannot cover a lot of things, so I try to limit. I will first I will share the lesson learned from my previous project on EV charging. So and then I will discuss about sustainable energy solution when it comes to EV charging, and then smart grid integration, and then we will see. I will share some information what's going on in Qatar now when it comes to electric vehicle, and then the presentation with the conclusion. So I would like to share, this is my previous project, one of the most memorable project that I had involved. So it was about 10 years ago. So in Malaysia, we started electric vehicle project very early. So it was triggered. The project was triggered during that time in 2012. Proton, automotive car company from Malaysia, and I see Proton, a lot of Proton here, especially in Turkey. So during that time, they would like to run a pilot project to have 250 EV and 125 charging station in the area of Putrajaya and Cyberjaya in Malaysia. So so the TMB is a main electric utility company in Malaysia, and TMB is also present in the Middle East, own and operating a few power plant and desalination plant in Saudi Arabia, Kuwait, and also has a strong presence in Turkey. And so the objective of the study is because the EV was still new, so they want to identify type of battery chargers and charging station available, and then conduct actual measurement at site where EV chargers already installed to see is there any problem with power quality, and then from the data gathered and with some projection to conduct comprehensive study on the effect of EV charging on the network. And they want to see from the perspective of planning, operation, and maintenance and construction. So this project is initiated by utility companies. So the result is not shared publicly, but some of the result is published in the publication that is listed at the bottom. So, but I will share some of the result of from the study. It was early 10 years ago, but still relevant today. So we listed all available charger standard, and then the EV charging capacity during that time it was 1 to 10 kilowatt for onboard charger. But now I'm seeing there is already up to 19 kilowatt for onboard charger, and for fast charger up to 250 during that time. But now we see 500 kilowatt is also already available. And then on the power quality, we investigate the impact of power quality on electrical network in terms of harmonic distortion, voltage fluctuation. And then we also found out with this EV we are projecting, there will be a system imbalance. And of course, with the additional EV in the system, it will lead to a cable and transformer overload. And of course, this new load will definitely change the profile, load profile curve in the distribution and even up to the transmission if the EV is very substantial. And there are many more findings in the report, but I cannot share due to some reason. But if you look on the right, it's in terms of harmonic. So because EV they were saying the EV is using power electronic inverter, so the harmonic will come to mind. But we investigate. But during that, we found out the modern EV, yeah, the voltage and current is very clean, almost perfectly sinusoid, compared to the upper one is actually from the golf cart, because golf cart is also considered EV. It is a vehicle with battery, and during that time there were no commercial, not many, even no commercial EV in Malaysia. So we have to study with a golf cart to see the harmonic propagation, and we found out in terms of voltage harmonic, so the impact will not be significant. If we have one car, for example, THD is only 0.8, and when we have 20, the THD is only 1.8. So it's not like addition of car will increase linearly the THD. So some of the result is can be obtained from one of the publications that is written in the middle. And on the right, if you see the problem in Malaysia was typical house has a load of 3 to 5 kilowatt. So if the EV is 10 kilowatt, then it's double. The load will be double. Also the transformer, distribution transformer is rated standard for 1 megawatt or 1,000 kilowatt. So one fast charger is already increased the transformer loading for 75% of the full capacity. So there were the identified problem if the EV will be integrated to the network. So and also in the charging time, we try to identify when will be the charging time for EV. So we look into different residential, commercial, and also office load and different kind of load. And we try to identify how this EV will change the load profile. And then, definitely EV will create some challenges. So especially if it's only fed by the grid. So there are many sustainable options available. So we can integrate EV charger with solar energy or wind energy. And definitely these are renewable. They are not always available. So battery storage is considered important. And recently there is a strong interest in green hydrogen. So solar energy and wind energy can be used to generate hydrogen and then convert to electricity using fuel cell. And this hybrid solution is more sustainable, and it will remove definitely stress on power grid, and also we will optimize the energy around us. So I just put all the picture on this slide because there are different way possible. So it will be determined by location and also the economic aspect. So so after the project, so we realize to have more sustainable solution. So we need to mix the source for EV charger. So we come up with a demo project. So we build a hybrid PV battery and of course connected to the grid. The original proposal was to include also fuel cell with PV generate hydrogen using electrolyzer and then convert to electricity using fuel cell. But the management during that time said said it was too dreamy because during 2012 hydrogen is still not very famous for electricity production. So the TMB go ahead to build this charging station. So to create awareness to the public and also to experiment what probably there will be another challenge was surfaced. So and also this is installed at TMB Research, one of the entity under TMB. So we also try to explore the intelligent charging management strategy, and also we try to explore vehicle to grid concept. This vehicle to grid concept will be covered by one of the speaker later. So and I'm moving on to the next slide. So in QEERI, I'm leading the project of smart grid. So we are seeing to reduce the impact of this EV charger to power network, we need to integrate the charging with a smart grid operation. So the idea is instead of a charge immediately when EV is connected, we try to wait until the energy is cheap or abundantly available, and then start charging. And also we are trying to explore V2G, as I mentioned before. And in QEERI, QEERI is a Qatar Environment and Energy Research Institute. We are one of the entity under Qatar Foundation. So in Qatar, there is a Qatar Foundation Education City. So we are trying to facilitate the introduction of renewable energy, especially PV, to a Qatar power system. So we we are building a lot of pilot project, demonstration project to introduce this new technology. So one of my activity under my project is we are building a 100 kilowatts microgrid test bed in the open area. So we call it open test facility. So it has a 100 kilowatt PV and then a 2 micro turbine, almost 100 kilowatt. And then battery storage. We are in the process of integrating the battery energy storage, lithium-ion battery, also almost 100 kilowatt. And we have a load, artificial load. And also we are going to integrate with charging EV charging station. So I cannot disclose information yet for this project. And later when it is, they will be in the newspaper soon. And just to share, before I end, this is next 2 slide. In Qatar, what is going on with PV now? I see Kahrama recently introduced EV and charging infrastructure guideline last year. So this is to control the EV charging, what type to be installed, the location to be installed. So this even this guideline can be downloaded from the link that I'm including. I'm listing here, and also last year, during the pandemic, also Kahrama, Qatar utility company installed one charging station with PV with a capacity 72 kilowatt peak, energy storage of 170 kilowatt hour, and it can charge the car less than 20 minutes with the capacity of 100 kilowatt. It's the picture on the right above top is the charging station. And recently Qatar announced 19 EV charging station is already been installed in one of the location. So it's a 180 kilowatt fast charger, which can charge less than in 10 minutes. And also there will be electric buses for in preparation for FIFA World Cup next year. So they already installed 2 stations for electric buses, and there are many charging, including at Qatar Foundation. And the plan is to add another 100 charging stations this year, and by 2022 should be between 200 to 50 charging points available. And most of this charging station is based on combo and Shademo type. So all this information are publicly available. If you click the link, I believe this slide will be shared. If you click the link, it will bring you to the page that has this all information. And something is interesting happening in Qatar. So next year for World Cup, Qatar is preparing to have 741 electric buses. So the good thing is 10 buses already here. So it's already arrived. The plan is by 2022, 25% of EV bus will be operating in Qatar, and 100% by 2030. And the charging infrastructure is provided by ABB. And you can see the picture. It's not artist illustration. It's a real picture. So the bus is from Yutong, from China. The charging station is from ABB. So it's already starting operation. And more information can be obtained from the link that is provided here. And on the right, you see this is the summary of the strategy for EV deployment in Qatar. So I don't want to take a lot of time. So what, as a conclusion, this is my view mostly. EV vehicle definitely will be one of the future transportation. So it's just a matter of time, and it is happening in Qatar. And EV charging will create new revenue for utility, but at the same time, it will create challenges. And one of the way to mitigate the problem with this EV is to have a different source of energy integrated to charging station, and also to control it using smart grid concept. so the energy system will be more sustainable. And from my perspective, Qatar is on the right track from if we are looking from the perspective of power grid security, reliability, and sustainability. That's all from me. Yeah, back to Engineer Saleh.
Thank you, Dr. Mohammed, for what you delivered already of interesting information about the sustainable solutions and the smart electrical vehicle systems. Also, we are excited about Qatar and its movement toward the electrical vehicle before the World Cup event. Please, Dr. Mohammed, stay with us during the discussion panel so we can have some more discussions with our audience. Thank you, Dr. Mohammed. And now we'll see if Dr. Mohammad Alam is ready with us. Dr. Mohammad Alam. Okay, well, now we'll move to our next speaker. He will be okay. Try to move the list. Now our the next speaker will be Dr. Ahmed Mousa. He's the founder of the Electrical Bridge Consulting. He will talk to us about the electrical vehicle grid impact and the future of the vehicle to home grid market. Mr. Ahmed Mousa, the floor is yours.
Thank you very much. Can you hear me?
Yes, we can hear you.
So thank you very much, Engineer Salem, for the invitation. It's great to be with all those great speakers. And basically, we'll just get right into it. So why EVs? So Dr. Mohammed gave you a very interesting plan for Qatar, and it's going to be very interesting, as they host the World Cup. All eyes right now are on the Olympics. So it'll be very interesting to have the World Cup focusing on the energy. So as far as EVs, why bother? So first point, we may not all have solar or wind or energy storage, but all of us somewhat either have a car, use a car, go on public transportation, subway, trains. So we have some kind of method of transportation. Or when you were young, you probably had one of those motorcycles in the picture. And even kids know, you play with it, then it doesn't move, you charge it, right? So a 3-year-old kind of have the concept. But what's interesting is, the quick role that EVs took, not just as a source or as a load, but also as a generator, as we will see. So I'm gonna quickly talk about the transition in EVs, what was the major change, and then talk about the vehicle to grid and the storage. So, as far as the EVs, size matter a lot. I will talk about a small EV, a medium, vehicle, large vehicle. So it's gonna be very important to talk about all the stuff. Touch a little bit about when to charge, because it's very critical. How are utilities addressing the extra load? Talking about the latest in the US, something called transactive energy, which I'll mention a bit. And then a lot of us have plans for ending the sale of the internal combustion engine. For example, in New Jersey, where I work, by 2035, you can no longer buy a car that's fueled by gasoline. So for the rest of the discussion today, I want you to think of a car not as a transportation, but as a battery. Right, that's kind of from today's discussion, right? Very simply, again, everybody knows what a battery is. Your kids know, the size. So what is the car? So an EV is a regular car plus all the following, an air conditioner, heating. Those two played a big role during major storms. Unfortunately in the US, Mother Nature usually is not on our side. A lot of you probably heard what happened in Texas. So if you had have an electric vehicle, at least you had some time of cooling, heating, it's an entertainment. Now your cars come with Netflix, Disney. You basically want to live at in your car instead of your house. For the dogs, they have the AC running, everything's good. And very important for today, it's a powerhouse. And even better, depending on where you are, it's a way for you to make money. So back in the days, a couple of years ago, EVs were very, very expensive. And now not only are they affordable, you're able to make some money out of it. Especially right now with COVID, many of us are working from home. So if you have your car just doing nothing, you could sell some power to the grid. So think of it, the car as a battery and a business. So there's a big push here and I'm sure everyone else, the important role of energy storage. We all have plans for 100% clean or renewable energy. Everybody knows energy storage will become a big deal. It could be storage plus nothing, storage plus solar, wind, fuel cell, DGs, nuclear, right, to help as a backup generator. The picture I have here, that's a small solar farm and 2 Tesla batteries. But really, it's all about everything. But what I'm trying to tell you is the same thing that in the slide an electric car could do. So again, we see the future, especially if you ever worked in the load flow perspective, that energy storage will try to be the balance between the time when it's not windy, not solar. Like right now, it's relatively humid day in New York, but it's very cloudy. So the solar output probably is close to 0. So maybe if we have storage, that would kind of fit in. So electric cars are even better because they're not just storage, they're mobile storage. So that bus that you saw, Dr. Mohammed, think of it for the World Cup, they move people to the stadium. For the next 2 hours, they're doing nothing. Maybe they discharge to the stadium and help out. So that's kind of the mentality you have to think about. So again, depending on where you live, a lot of us have an electric code X by Y. So a certain percentage of clean or renewable energy by 2030. For some reason, 2030 is very popular. I don't know why. And 2050. But some places, like I live in New York, it's 2040. So, the time shifts around. But we have goals for clean energy, for solar, for storage, wind. And most importantly, for discussion, we have goals for electric vehicles. If you're following President Biden in the US, he already announced he's going to convert every single government vehicle to electric. So we're talking about almost 700,000 cars become electric. A lot of utilities have their own plans. I'm not just talking about small cars, even bucket truck, very large. We have a big push by FERC, which is kind of like the Ministry of Energy in other places. They have this order called 2222. Basically, it's almost like a peer-to-peer energy. So just imagine, like I live very close to Engineer Salem. Maybe he has a house with solar, storage, electric vehicle, and for whatever reason we lost power, then he's able to send power from his house to my house. So again, it's a great time to be in this business. As far as planning department, right? It's very easy. I worked in planning for almost 18 years. So you have X over Y, load over capacity. If it's more than 100, we have an overload. If it's less than 100, it's great. If it's equal 100, we're there. So really, electric cars could really help a lot by doing 2 things. Instead of course, it increases the load, but if you charge your battery right, then you could help to shift the peak, as you will see. But it will act as a source as well. So why are we talking about electric cars now? It's really not new because there's been a major transformation, right? So cars are actually very cool now. You want to drive one. Again, they're very fast, they're very strong. They're no longer this ugly looking car, as I'll show you a picture later. But the electric manufacturer, they managed to give us something we really want to drive. As far as buses, right? The electric school, the school buses, usually they're very dirty. If you drive behind one, it's black smoke coming out, our kids go there. But a lot of states now have been converted to electric buses. Why is that great? Because usually you have no schools in the summer. A lot of utilities peak in the summer. So those buses could be basically a mobile generator. So that would be great, hundreds or thousands of buses driving around and basically helping the grid. In New York, she's very famous for the New York yellow taxi cab. You look at the picture to the left, and I look to the right, they're being replaced by Teslas, right? So that's a great thing, right? So they're there, they're cleaner, they're more efficient, and it's better for the customer. So again, the point of those slides is the major transformation on every level. This picture I took in California, so even the boats now are electric, so clean for the marine. You can see the picture on the bottom, you're charging the boat. So kind of same concept, right? So the point of this, if it moves, is going to be electric, which is here. Again, if it's a bicycle, skateboard, hoverboard, no board, the flying board. So again, I want you to think from your perspective for the rest of your life, anything that moves is going electric. And the reason I mentioned that, because that was what the electric car looked like. It's not the nicest looking car you want to be seeing in compared to all the newer ones. So again, that's kind of, this picture is already old, but we went really from this soap looking car to this. So cars are one thing, but we're very interested in the performance, in the looks and the speed. And that's kind of the beauty of the electric cars, right? So there's a lot of videos you could see online of cars, they're competing with extremely fast, extremely expensive cars. So again, the market was able to give us something cleaner for the environment, cleaner for the public, for our kids, It's more efficient, it's cheaper. I mean, right now the gas prices are rising a lot in the US, so they definitely offer a service. And not only that, but they have a way of earning revenues by supplying to the grid. Here's a picture. I mean, if you compare the price, there's a lot of extra zeros here. You have a car that is faster than a $3 million car, and it costs only $200,000. So again, electric vehicle initially was meant for the very, very wealthy environment. Now you have different styles. But again, all the stuff, putting stuff aside, again, electric motorcycles as well are making a lot of noise here. And Formula E, I know that Saudi Arabia hosts a couple of these events. I was fortunate to be the one in Brooklyn. It's a great race. So again, the point of all these pictures is that electric vehicles are basically almost in everything we do in our life. Transportation, pleasure, entertainment, they're gonna be a power resource. And Dr. Mohammed showed you again the picture of buses. Here just a picture from New York City. And as far as the medium and large vehicle, here are the large garbage trucks. So why am I showing you a lot of these pictures? Because a lot of, for example, the picture you're looking at right now, those buses, you know, or the trucks, they have a certain route. They only operate in a certain time frame. So there's, for most of the time, they're idle, doing nothing. So instead of having, like, for example, a very slow charger, you could have a fast charger, and then you could utilize this power to discharge somewhere else. Maybe during a major event, like a major storm, or during like a blackout or something like that, those trucks will be dispatched instead of collecting garbage by helping the grid. So all this stuff is great, but for the last couple of years, I mean, we've been working in electric vehicles almost at least since I started in New York City in 2006, but the forecast was very, very poor, almost like the weather. We have a lot of cars, nothing, so it wasn't that great forecast. There's a study available online that in New York City we did with McKinsey and the mayor's office. It dates back, we did the study almost in 2008. So 13 years ago, it's a great analysis. You could Google it to learn what's the impact. But really, to get to the technical part of this presentation, I personally believe that the future, you gotta meet the 3 R's. Must be reliable, must be resilient, and must be renewable. At the same time, you know, when I always say when it goes dark, no one thinks about the green energy, but they want reliability. Mother Nature, I mean, if you saw the weather last week in Germany, China, Switzerland, there was like 7 or 8 countries completely flooded, so we need to change. So you need all this stuff, the importance of data, we need a lot of data to have a stable system. So the question that I have for you here is, do you think, just want you to think about it, do you think EVs can help? In my opinion, they definitely can. They could help with the stability by becoming either a load or a generator. They increase the reliability by helping the grid disconnect, almost act like a nanogrid. So again, moving on. Another acronym is the future's 3D. So distribution is going to play a very, very important role. Most of the pictures that Dr. Mohammed showed and most of the EVs will be charged directly from the distribution system. So we need, you know, to build a robust distribution system. We need to connect more distributed energy resources, and you need digitalization. So for us, a lot of utilities are relying on our distribution management system, our DER management system, DERMS, to be able to control the impact of EVs, right? If you do it right, there's no problem. Here's the picture I found online. I mean, I forgot which country, but if you look closely, almost 90% of the houses have solar. But then look at those. I mean, I just circled some of the ones. So in the future with this transactive energy, you know, maybe those that have solar and other resources, they could help out. It's almost kind of like a community support. So electric vehicles will play a major role in helping during storms, you know, blue sky day, to help with the grid. So again, we're able to, just quickly for the sake of time, we need to have the simple as very, very easy. It needs to be for every planner, for every designer, for every engineer, that the electric vehicles and energy storage become a great tool. And then all the stuff is great, but it's all about the charging, the whole charging stuff. So if you were to analyze any utility, any system, you always read about that electric vehicles may have a major impact on generation, transmission, sub-transmission, distribution. And that's all 100% correct. But one of the way really of managing all this stuff is when to charge. So similar to, you know, there's a lot of websites tell you what is the cheapest gas station, because in the US, every gas station has a different price. So it's a similar concept, right? So a lot of utilities have rebates. For example, if you charge at night, basically it will cost you less to charge your car. Some locations, and maybe hopefully in the Middle East very soon, when you have a lot of solar, so you could charge around noon, right? Because you have abundance of solar. Maybe areas with a lot of wind, if you charge like 1 o'clock in the morning, So you kind of get the concept, right? So I think the charging will be almost a case by case. It's a function of your available resources. That's kind of very important, right? So the time of usage, what's the benefit of having all the stuff? Again, I'm just showing you a curve here on the top one for the solar curve. So it's a clean day versus like a very, very nasty cloudy day. So the EVs could kind of help. So Dr. Mohammed mentioned the fast chargers, and I think the future, you're going to see a lot of fast chargers. And in the very near future, in my opinion, you're going to see some fast chargers at the customers' houses as they get cheaper. They want to charge fast. They don't want to wait 8 hours or 6 hours. They want this few minutes. That will put a great impact on the grid, as I'm going to show you. Again, I want to think of the car as a portable demand response program. For example, let's say right now we're having this discussion. An hour from now, the discussion is over. We act like an Uber almost. You get a signal, hey, the next street has an issue. Go park your car there, make some money. So that's kind of be the concept. And as you know, a lot of those cars are right now have autonomous driver. So you don't even have to drive anymore. You send your car with the signal, it goes there, automatic connection, everybody wins. The price varies a lot based on location, based on system events. So what do you perform if it's a sunny place, windy place, hydro, and so forth. So the electric vehicles will be there to address the overloaded areas. There's a big push here also for something called non-wire solution when customers support the grid. So electric vehicles will be a great support. Just very quickly coming towards the end. So if you don't have a proper management, really the electric vehicles impact everything from the customer's house, but the customer is responsible for the meter. So you may put a bigger meter. The service drop, which is the last point between us, the utility and the customer. The overhead transformer itself, the 120 or 220 volt line, the branch to the fuse, the primary feeder. So you get the point. So the single car impacts all the way back to generation. So the beauty of that is you could address all this item by the vehicle to house or vehicle to grid. And one point just to bring it to your attention, just for sake of time, is that if all the electric vehicles charge at one time, that may impact the fuse. If they all charge at night, then basically the load curve becomes a little more flat, and that may impact the rating. So just very quickly, here's some pictures, right? So this is the impact, the service drop, the overhead transformer, the line, right? Here you probably have the primary circuit. So if you don't manage properly, you impact all the way back to the system, up to go to substation transformer. So again, the more EVs you have, and you learn from Dr. Mohammed how large the EVs are coming, and they have planned to charge a car less than 10 minutes. That's a lot of load. And I mentioned before, a lot of cities have plans to get rid of, internal combustion engines. So if everybody's driving a very large car, what's going to be the impact of the grid? And then it goes up. So it goes up all the way from your house to the transmission and finally to the generation system. So unless we plan this right, so really, this is kind of my last slide. So there is definitely a market right now for a vehicle to home, vehicle to grid, and there's something called vehicle to eye. So any entity, you're able to use your car to supply. There is some revenues, there's a lot of advancement in California first, as always, and then the rest of the places. So we are addressing all the stuff. So I know that by telling you smart charging, everybody knows that. But smart charging is really almost in a case by case. So as we have smart meters, as we know the load on every street, we have to get to the very, very customer level, because maybe that street could handle the load at 9 p.m. The second street could handle like at 10 p.m. and so forth. So, with the education for the customers, for the vehicle to grid, I think we could easily quantify the method. So again, I'm looking forward to the discussion we're going to have. If you guys have any questions or comments, but I'll leave you with this. Think about the FERC order 2222 if you want to Google it, and the transactive energy market. And again, every time you see a car, electric car, think of a car as a battery and not just as a transportation. So thank you for listening.
Thank you, Dr. Ahmed, for what you gave us of information about, how important to deal with electrical vehicles in our grid, and also how it will affect positively and negatively if we don't have a good management techniques or systematic way of dealing with the network. Thank you, Mr. Ahmed, and we will be discussing more during the discussion panel.